très heureux aujourd'hui d'être parmi vous et très honoré. Et je vais faire la présentation en anglais. Donc, so the talk of today will be water resources and security challenges in the Orontos River Basin. So quickly for the outline, we're going to start with the setting and then some water uses and optimization results, current water agreements, water security challenges, and conclusions. So today, what are the transboundary river problems? First, you can have disasters. So, for example, this was a picture taken from the Zayzoun Dam in Syria after it was collapsed. It's on the Orontos River. You can also have scarcity of water, for example, in Jordan. Also some degradation, so pollution, and this is in Syria. And maldistribution, so inequitable access, for example, in Palestine. So currently, what are the observed problems? First, you have hydric stress in the Middle East. So if you look at the blue water availability benchmark of 500 cubic meters per year, Israel has about 325 cubic meters per year, Jordan 140, Lebanon 182. So you have excessive water diversion and dam building. You have drought conditions and the deterioration of the water quality. Now, in terms of hydrologic modeling, currently there is no basin-wide study that exists on the Jordan River Basin of precipitation minus evapotranspiration. So in our research at University of Texas, we got all the data from the satellite from NASA. And secondly, no rainfall runoff modeling of the Hasbani Basin exists. So this is what we did also for Lebanon. Now, other observed problems, for example, are political. So you have only bilateral agreements. You don't have more than 2 countries involved in the agreements. For example, Israel, Jordan, Syria, Jordan, and Lebanon and Syria for the Orontos River. You also have territorial issues. For example, the Golan Heights problems, the Shebaa farms, and the Hatay province in Syria that we will talk about in the Orontos. Actually, for example, the plane that was crashed from the Russian, it happened in the Hatay province, so in the Orontos Basin. Another difficulty is the database. So first of all, you have to link the water data to national security. Every country does not want to share this information with the other riparian countries, so they keep them to themselves. And secondly, there is inaccessibility to hydrological and meteorological time series and background data. So that's why the use of satellite data is very useful. So what we did is we built an ArcHydro data model using ArcGIS to facilitate the integration of spatial, temporal, hydrologic model into a relational database. So what we did is we gathered some data pertaining to the watershed, the water body, lakes, rivers, streams, and hydro points. So what are hydro points? They are stream gauges or meteo stations, for example. So all of this was inserted into a time series that then we were able to define the boundary of the catchment. So first we start with the DEM, digital elevation model, from the satellite. So this is mainly elevation. Then you remove the pits, you calculate the flow field, so you can have your streams. And finally, you come up with the flow-related terrain information. So as you all know, we came up with this map of the Orontos River watershed. So basically, the Orontos River originates in Lebanon. I don't know if you can see the mouse. So the headwaters are in Lebanon, in the Bekaa Valley, at about 400 meters above sea level. And then the water flows through Syria And finally, you have two tributaries coming from Turkey, the Karazu River. The Karazu River starts in Turkey and then forms the border between Syria and Turkey. And then it re-enters the Turkish territory. And the Afrin River also starts in Turkey, enters Syria, and then joins the Orontos River. This river discharges into the Hatay province in the Mediterranean Sea. As you can see, there are a series of dams. Many dams are built on this river. They are located in green crosses in this map. And also you have two main agricultural areas, the Rab region, which is in Syria, and the Amik region in Turkey. Now let's zoom in on the Lebanese part. So if we zoom in, we see that Lebanon has built two dams on the Orontos River, a diversion dam and a storage dam. Also, you have two agricultural areas, the Hermel and the Ka. And in 2010, part of our research, we installed, with the Italian cooperation, we installed 3 meteo stations. So now we have about 6 years of data to help us in the modeling. So I'm not going to talk about all the factors we looked at, but we looked at the UN 1997 Convention, and especially Article 6 pertaining to reasonable utilization of the waters. So we looked at geography, for example. As you can see, the biggest share of the basin is in Syria, with 69%. And then you have Turkey with 22%, and 9% of the basin is located in Lebanon, with a total area of about 24,700 square kilometers. So I was talking about satellite data. Just a brief introduction about the MODIS satellite. It's a satellite that was launched in 1999 aboard the EOS-AM mission, and then it followed another mission in 2002. So the MODIS takes images of the entire Earth every 1 or 2 days at 1 kilometer's resolution. So we took this data product provided by NASA, and we were able to calculate the evapotranspiration in the entire basin. So you can see that the evapotranspiration can vary and can get to 1,200 millimeters per year. So we took an average of this evapotranspiration for 10 years, and we calculated the mean evapotranspiration over the entire basin, and here is the ET for every country. So Turkey has the highest ET with 312.8, Syria 260.4, and Lebanon 221. So with this, what you can calculate is if you have the precipitation that we also got from a satellite, and then McKinney will talk about this, we were able to calculate the precipitation minus ET to give us the contribution to annual discharge. So the annual discharge is almost equal for Syria and Turkey. They are both providing about 45% of the waters. And then you have Lebanon with 11%. Now, the water use in general in the basin, historically, Turkey and Lebanon have used less water from the Orontos rivers than Syria. And according to the FAO, you have about 58% of the irrigated land in Syria, 36% in Turkey, and 6% in Lebanon. Now, specifically for Lebanon, we are currently irrigating about 1,700 hectares. And after the Syrian-Lebanese agreement of 2001, we are allowed an expansion up to 7,200 hectares. So in Lebanon, you have it's basically the water is used for recreational use, but you also have fish farms and irrigated lands. So with all this data, we were able to calculate an optimization formula in order to look at how much each country should receive in percentage. So we didn't look at absolute value, but we looked at the percentage point, because in case of a climate change, you cannot allocate an absolute value of water to a country. So we made it simple to be used in Excel spreadsheet with some criteria for countries. For example, the most populous is Syria, the most flow contribution Turkey, greatest current use Syria, and so on. And the weighting was adjusted to each property, so that during negotiation you can have a country-centric political weights versus water scientists. And at the same time, we had 2 surveys. So the first survey was done by the water experts from a previous publication. And as you can see, it's interesting because the water experts gave the most weight to existing utilization. Whereas the class I was taking with Dan McKinney, they gave more weights to the socioeconomic factors. And these factors, they are the 9 factors that we used in this formula. And the optimization results, so survey 1 from the water experts and survey 2 is the class survey. As you can see, Lebanon for survey 1 received about 27%, 47% for Syria, and 27% for Turkey. So in general, Lebanon and Turkey should receive the same amount of water in percentage, and Syria would receive the highest amount. Now, we ask ourselves, is this UN convention useful? In terms of for a diplomat, we just heard it in the talk before, it's a challenge to the status quo, it's an invitation to engage. But for a strictly water modeler, it's actually a naive and imprecise. Because as you can see, the discrepancy in the data, in the results. So now I'll pass the floor to Dr. McKinney, who will start with the hydrologic modeling. Thank you.